my audio is clear, right? Someone can confirm? Yes? My audio and presentation is clear, right? Yes, Manoj, thank you. Pawan Kumar, thank you. So today we'll be learning a small session about Node MCU and ESP8266. So MCU is nothing but microcontroller unit. Node is nothing but the complete device is called as node. Okay. So the board number is, or the naming convention is called as ESP8266. What is Node MCU? Node MCU is an open source development environment built around the ESP8266 Wi-Fi module. So ESP8266 is built based on Wi-Fi. So to make an embedded system to connect it to Internet of Things, we need basic thing is either communication protocol, either by using GSM, okay, using 2G internet data or 4G internet data or 5G internet data. We have to send the data to internet application, either Android app, iOS app, or web application. So to make all this complexity in Arduino or any other microcontroller board at Mega 8 or 8051 microcontroller board, okay, the advancement in the technology made to connect it to directly to the Wi-Fi using ESP8266 Wi-Fi module. It provides a platform for Internet of Things. Clear? Hope you are able to understand the topic. So how we will be connecting the Node MCU? The Node MCU, this should be the access point. This should be the station mode. And we can connect these two connect these Node MCUs in a Wi-Fi network. And to this, any of this Node MCU, we can connect mobile data and laptop data. Clear? So in brief, the Node MCU, okay, input voltage is operating this micro USB of 3.3 volts and 250 milliamps. And RAM is 160 KB and DRAM is 96 KB and flash is 4 MB. So as usual, I am telling you, so all these memories are related to the programming, code, and control registers. It can be organized in such a way that based on the microcontroller architecture. Features of Node MCU. The main feature, of the Node MCU looks like Arduino, and the platform or the IDE where we can connect is using Arduino IDE. Okay. Among all the Wi-Fi board, okay, ESP8266, the programmable pins on the both either side, you can see has the programmable pins, and the silver color module on the top with an antenna of square wave. Okay, here this is called Wi-Fi. So usually Wi-Fi chip consists of transmitter, receiver, clock generator, and power unit. So already this is having the transmitting antenna and receiving antenna on chip, okay, and or on board. When we power up, the power from these pins will be circulated to the board of Wi-Fi chip. Similarly, I'll be showing you both the differentiating modules physically, okay, and when we power via USB in this, right, the power from the main ESP8266 board will be circulating into the Wi-Fi chip. And it is hardly almost all 200 to 300 or 400 rupees of cost. It is low cost microcontroller device approximately, and which can meet our basic Internet of Things requirements. Okay. Hope everyone is following and understanding what is Node MCU and how we are using this Node MCU in IoT. Hope everyone is with me. Everyone is following my presentation. Yes, thank you. Someone has confirmed. Next. Node MCU integrates the ESP8266 Wi-Fi module with a microcontroller unit, making it easy to connect it to Wi-Fi networks and perform IoT tasks. It also supports Lua-based programming. So, as we have said, okay, 8266 ESP8266 is a Wi-Fi module with a microcontroller unit. Okay, this chip or this board is made to connect easy with internet using Wi-Fi module. And using this Wi-Fi module, we can program the IoT data. The programming language we can use is same. What we have done using the Arduino IDE, the embed C code we have downloaded and uploaded to the microcontroller. And apart from this, ESP8266 supports Lua-based Lua-based scripting programming language. So this is some scripting programming language which is related to Linux. This similar kind of scripting programming language also can be uploaded or downloaded to this ESP8266 Node MCU microcontroller. What can we do with it? Program it in C or Lua. So as we are familiar with embedded C and C programming, we will be going with C programming. And access it via Wi-Fi using HTTP protocol. There are input and output pins. So as this slide explains, the basic architecture or the block diagram of ESP8266 D0 to D7. Sorry, D0 to D8. Those are data pins. Okay, and whatever the pins we have, those pins are multi-purpose programmable pins. You can see each and every pin is having one or two functions, and some are having more than two functions. Coming from the right bottom, there is a flash button and reset signal, and this is the power unit, 3.3 volts, ground, and these all white color pins are general purpose input output pins. Totally we have 3 power supplies and 3 ground pins. 4 ground pins, sorry. On the complete board, we have 3.3 volts power supply pins and 4 ground pins. And GPIO 1 to GPIO 16. We have general purpose input output ports. Shiva, I'll be answering these questions in the later. HTTP protocol routes S3. S3 is nothing but a storage bucket in Amazon AWS. So I have never tried. So it should communicate, I hope. I never tried it. So I'll check and let you know, Shiva. Okay. I'll let you know, Harsha, what is enable pin and everything. So I'll explain all the pin diagram. So whatever the white color pins are there, GPIO 1, GPIO 2, GPIO 3, GPIO 16, all those are general purpose input output pins, like digital pins. And apart from these digital pins, some pins are acting as UART, TX1, RX2, RX1, TX2, RX2. TX0, RX0. All these are UART pins, the light blue color ones in the right side. Okay. And the top D0 pin is used for user mode functions, and D3 pin is used for flash mode functions. So whenever we press this flash button, okay, the pin or the LED near to the D3 will be flashing. And based on the wake on mode, so sometimes what we'll be doing, we want to turn on our laptop remotely. We'll be using wake up mode, right? So similarly, whenever the microcontroller board ESP8266 is shut down, okay, and it is powered up, okay, but there is no functionality working on, then based on the connectivity, Lokesh, Uma, hope my voice is clear. Lokesh, are you able to hear me? Banu, you able to hear me? Yes, yes. Banu, confirm. Thank you. So D0 pin can be used as a wake on LAN, like wake on Wi-Fi. Voice and video. Video is not there. Only voice. Okay. And the video is related to the screen share or the presentation. Okay. Prabhu, my voice is clear, right? Confirm? Yes, Nikita. So D0 pin, we will be using it as for wake on LAN. So whenever my board goes into sleep mode or ideal mode, I want to wake it on by LAN. So I'll be using the D0 program to wake it on LAN based on the timer function or based on the clock function or interval or any task or function. Example, to save my energy of so completely my ESP8266 is 3.3 volts. If this is deployed in a remote location based on solar power and battery operated, I want to save energy of battery. Okay. So in the daytime, I need to capture the solar energy. In the night time, I need to turn on the street light. Then what I will be doing? Directly, I will be making my ESP8266 node MCU board going to the sleep mode and give the directly battery power supply to the street light LED lamp. Whenever it comes in the morning, so as usual, we know that we'll be connecting it to the real-time clock. Based on the real-time clock, we'll be asking the ESP8266 board to wake on and charge my battery. This is how the wake on pins works. And the green color pins, you can see HS clock, HM ISO, HM, OSI, HSC. So all these pins are related to serial communication, which are related to I2C. I2C is nothing but interconnect communication protocols. This is little higher version of UART. And the other left side green color pins, you can see MOSI, chip select, MISO, SCLK. So these all are SPI pins, which are called serial peripheral interface. So what are the serial communication chip pins we have? On the ESP8266, we have UART, I2C, SPI. Based on the user application, okay, then we can connect the or communicate how many devices we want to interface with the ESP8266 node MC. So I2C is a single master, multiple slaves mode, and SPI is a multi-master, multiple slaves mode. These all are serial communication protocols. And on the top left, purple color, ADC 0. We have one ADC. Okay. And next is SDD3, SDD2, SDD1. SD clock, SDD0. All these are related to the serial data communication. And the light orange color pins enable and reset. Enable is nothing but based on the enable, okay, which protocol or which feature of the pin we want to use, we can write the enable pin. And the reset pin is completely resets the microcontroller and Wi-Fi chip. It will start from the initial. Hope this slide is clear. If you have any questions, please post it here. I am able to see your chat. Clear this slide? The pin diagram, the interfaces, and the multiple functions of the pin diagram of Node MCU ESP8266. Right. Thank you for the confirmation. So Node MCU architecture, which comes from the family of ESP12E module, main processing unit containing the ESP8266 chip with built-in Wi-Fi connectivity, and the CP20102. This is USB to UART bridge. The black color one here, or CP2102. This pin, this IC. This IC is used to USB to UART communication to dump the code serially to the microcontroller. Next, flash memory and RAM memory. GPIO pins functions. Node MCU development board. So as we have seen, this Node MCU is called as a IoT development board. Integration with ESP8266. Which has USB interface, voltage regulator, GPIO header, USB connectivity, expansion pins and capabilities, like we can connect many amount of sensors, displays, and actuators using different protocols. And the programming environment, as we have seen, based on the engineer or the user or the developer flexibility, which programming is familiar. C programming, the students or the developers who are familiar with the C programming, they can go for Arduino IDE. Okay. The students or the developers who are having knowledge on Linux and scripting, they can proceed with Lua based programming. Next is understanding ESP8266. ESP8266, we have told that it is having inbuilt Wi-Fi module, which follows the TCP/IP stack protocol and which operates at a 2.4 GHz Wi-Fi band and supports IEEE 802.11 giga bandwidth. The key features of ESP8266 module offers 32-bit processing and 16-bit instruction set code and designed with the Harvard architecture, where the instruction memory and data memory are separate. Okay. Apart from Harvard architecture, what is the different level of architecture we use in microcontrollers or microprocessors? Someone answer me. What are the two different types of architectures we use in CPUs? like microprocessor or microcontroller. Has the key feature ESP8266 has 32-bit processing and 18-bit 16-bit instruction set, which follows Harvard architecture. And Ramya, you are intelligent. Thanks. And the next architecture is von Neumann architecture. In von Neumann architecture, the instruction set and data memory both are sitting on the same. In Harvard architecture, Kashim, I am just explaining, understanding about ESP8266 features. ESP8266 is a Wi-Fi chip, as you see in the image. Okay, this ESP8266 is the Wi-Fi chip where we are separated from the onboard of Node MCU. This chip is having 32-bit processing unit and 16-bit instruction set computing. And whereas we have understanding about memory, that is instruction memory and data memory. Instruction memory is nothing but where we write simply programming code. That kind of code is called instruction set computing. And where we pass the values or where we read the values from the environment to the microcontroller, all those are called a data memory. Both memories are separate. That kind of architecture is called as Harvard architecture. Kasim, you understood now? And whereas the instruction memory and data memory both are sitting on a same type of memory, then it is called as von Neumann architecture. Clear so far? Someone please confirm. Yes, Gayatri, thank you. So this is a simple block diagram or a detailed architectural programming, like detailed architecture of programming of ESP8266. Okay. So the blue part is ESP8266 and the yellow part is Node MCU. That is microcontroller unit. And the blue part is Wi-Fi chip and the yellow part is microcontroller unit. Clear? So each and every component, if you are looking, the interfaces from the right side of the microcontroller, interfaces are nothing but yeah. Harshavardhan, we have a reset pin on the board. That is hardware reset. So if you want to do some software reset, you have to write in the code. Clear? Is this clear, Harsha? I am moving back to the block diagram. Okay, sir. So the yellow part is microcontroller and the blue part is Wi-Fi. So coming into the hardware, right to left, okay, the interfaces. No. This is not related to artificial intelligence or ChatGPT. So we are learning about Internet of Things. So everything we are learning on the hardware. Whatever the ChatGPT is doing, that is software program, and they are using many kind of programming languages. Okay. So this is not related to ChatGPT or generative AI. So we are using IoT. Our main course is embedded systems and IoT. So embedded systems is nothing but combination of hardware and software. And IoT is nothing but embedded system sending or receiving data from the internet. Clear? Hemant, did I answer your question? Hemant, can you please reply? Yes. Hanuman, all the presentations will be shared. So in detail, when we are programming about the ADC, I will be letting you know about 8266. What is the sampling rate or how many channel ADC it is? What is the packet size? How many bits it can read and all those things. Okay. So the interface part we are using all GPIO, SPI, SDIO and I2C. These all are interfaces part. Next one is PMU. PMU is power management unit. SRAM is nothing but whatever the programming code, instructions or data, whatever we want to store, that is stored on SRAM. And next is CPU. CPU has registers, sequencers and accelerators. This completely called as microcontroller unit. And from the microcontroller unit, we are interfacing the data to send it to internet using digital baseband. If you want to receive serial data input output, SDIO. If we want to send the data or receive the data from yellow portion to the blue portion, we will be sending the data using analog receive or analog transmit based on the clock signals, that is using PLL. To run this PLL, we need the PLL circuit with crystal oscillator. Crystal oscillator will be connected to the power supply, PMU and biasing circuit. Okay. This will create the vibrations in the PLL. Based on the vibrations, we generate a smooth clock. Using the smooth clock, based on the clock signal, either we want to transmit the data from microcontroller to the environment IoT outside or receive the data from IoT outside environment to the microcontroller. We use analog receive and analog transmit. To receive analog receive and analog transmit, we will be using radio frequency signals. That is RF receive and RF transmit. Based on the usage, either receive or either transmit, the switching action will happen here in the switch. And the RF band signal, whatever the chip antenna we have seen in a square wave, that antenna is called as RF antenna, which is connected to RF balloon. It is full duplex. It is full duplex, but it will switch between receive and transmit. What it has to receive from the outside environment and what it has to send it to the IoT outside environment. Clear so far? This slide? Dear engineers, the architectural block diagram. If yes, please confirm. If you need any questions or explanations, we'll proceed. Okay, so I'm moving to the next slide. This is ESP8266 Wi-Fi module pin out diagram. Okay, this is LED. Every time I will be starting with right side. Okay, all the pins are multi-purpose input output pins. The green color pins are general purpose input output pins. And the below green color pins are related to the SPI. And the two blue color pins are related to the UART. And in the left side, we have seen that we have SDIO and wake on LAN and timeout and UART clock signal, UART TXT, UART RTS receive signal. So here is a brief example. Peripherals, 17 GPIO pins we have. D, GPIO 0 to GPIO 16. So those all are 17 GPIO pins. SPI, serial peripheral interface. I2C, integrated circuit. I2S, serial, integrated serial links, interfaces with the DMA, dynamic memory access. You are 10-bit ADC. So you have asked me a question, someone, what type of ADC we have? We have sigma delta modulator ADC, which is of 10-bit ADC. So whenever we connect an analog sensor directly to the ADC pin, yes, these classes are recorded. If you are not following, please ask me a question. I will be clearly explaining you. So someone has asked me a question. What type of ADC we have on ESP8266? ESP8266 has 10-bit ADC which operates on a principle called sigma delta modulator. Okay. Attendance all will be taken care by Blackbucks team. Next is analog input pin. So we have A0 has the analog input pin on ESP8266. The input voltage ranges from 0 to 3.3 volts. So as I have said you, the ESP8266 development board has LED on GPIO2 pin. So where is the GPIO2 pin? On pin number D4. Near to the D4, we have a LED. Near to the D4 pin, we have an LED, but here it is not printed on the board. Okay. So physically, when you check, we have a pin on LED pin on this board. Next is reset pin. The left side of the power USB. See, when GPIO 0 is pulled low, it sets ESP8266 into bootloader. So when we connect this GPIO pin, these are the special functionalities. I have said to you, all the multiple pins of ESP8266 functions has multi-functions. Each and every pin has multiple features. Either it acts as GPIO, either it acts as transmit or receive, or SPI, or I2S, or I2C, or any kind of feature it has. So coming to GPIO 0, when the pin is connected to ground, okay, and when we press the flash button, okay, then this ESP8266 will go into a bootloader mode. Bootloader mode means as a bare IC, when we have connected it to the board, we need to add some firmware code. That firmware code will be loaded as a bootloader code on our serial monitor when we connect it to Arduino IDE. Next is GPIO 16 can be used as wake up. As we have seen on the top, GPIO 16 not only works as general purpose input output port, but it also acts as wake up mode. When it will be working as a wake up mode, the GPIO 16 pin should be connected to the reset pin. Where is the reset pin? On the board, the left side. Okay. Third pin. This reset pin has to be connected to the GPIO 16 pin. Then we can make it as work as Recon pin. This is how the inbuilt firmware code works on the ESP8266 as a combination. Hope you are clear. If you have any question, please repeat in the chat box. I will be answering it. So I'm explaining how we are going to use the multiple features of ESP8266 breakout board or the pins. Sampling rate. Exactly. What is the sampling rate? Sampling rate is nothing but the amount of data it is transferring. So if we consider ADC, ADC is supposed to transfer how many amount of data? It is sigma delta modulator 10-bit sampling. For every clock cycle, it carries 10 bits of data. Clear? The rule number 402. Banu Sairam, I am just explaining what are the pins are and how we are using. So I am telling you, when my flash or bootloader mode is working. So when the flash or bootloader mode is working, when I connect my GPIO 0 pin to the flash button, when I am connecting this GPIO pin to the ground, then when I am pressing this flash button, I am connected it in the flash mode or bootloader mode. Bootloader mode is nothing but initially when you are starting your laptop, okay, you are going to the bootloader just to check how much amount of disk is there, how much amount of RAM is there, what is the clock specifications, and you want to boot from USB drive or hard drive or any flash drive. That is called your Windows bootloader. Similarly, we have ESP8266 bootloader. So when we are connecting the GPIO pin 0 pin to the ground and pressing the flash button, okay, my ESP8266 will be working as a bootloader mode. And next point is when I am connecting the reset pin, you can observe my cursor. The reset pin physically connected to the GPIO 16 pin. I can make this board has wake on internet, wake on LAN or wake on Wi-Fi. And clear, Banu Sairam? I have explained it one more time. And Sivananda Reddy, why the clock only carries 10 bits, sir? So the sampling rate is nothing but it is nothing but like baud rate. How much amount of data can be carried in n clock cycles is nothing but it is n bits of data. That is how the definition sampling rate comes. So all these circuits which are working, or when we write the program to the ADC, the sigma delta modulator is nothing but it will be working based on the ADC sampling rate. How to get high sampling rate? So you need to design your own ADC to get high sampling rate. As the board is capable of capturing only 10 bits of ADC, so it is capturing only 10 bits of data in a given clock amount of time. If you want to assemble any external ADC, you can assemble external ADC and connect it to the GPIO pins. Okay. directly to read the digital data, and you can program your own ADC IC externally. If you can buy some ADC IC externally, which is having higher sampling rate, okay, Alluri Naga Triveni, if you want to interface high sampling rate ADC IC to ESP8266 node MCU, you need to use another chips. Else, you have to design your own ADC. There are some ADCs which can capture 8 bits, 10 bits, 12 bits, and there is some high precision ADC which can capture up to maximum 16 bits, I think. To my knowledge, I have never used. Maximum I have is 12 bits ADC using sigma delta sampling. Clear? Triveni. Sivananda Reddy. Is this clear? Explanation. Can I proceed further? Yes. Triveni. Banu, thanks for the confirmation. Again, explanation. Yeah, Triveni, thank you. See, whatever the pins we have seen, the pins description, SSCL, GPIO5, and GPIO4 SDA, serial data, and SSCL is serial clock. These two pins are called as I2C. This is another mode of serial communication. For now, understand this much only. Okay. And next is the 4 pins of serial communication. Master in, slave out, MISO. Master out, slave in, MOSI, serial clock, and chip select. These all pins programmed together called as SPI, serial peripheral interface. And there is an interesting feature hidden, PWM pins, GPIO 0 to GPIO 15. All the pins are software programmable 10-bit resolutions PWM pins. So as we have seen in the previous example of Arduino IDE ATmega 8, ATmega 328 microcontroller, we have seen PWM pins on Arduino board externally. We did not write any program, just we need to connect the PWM and initialize the pins and ports and to function directly as a PWM. Whereas in ESP8266, we have a software PWM where we need to program GPIO 0 to GPIO 15 with 10-bit resolutions. So as we are interested in the microcontroller or microprocessor architecture, we have software interrupts and hardware interrupts. The basic hardware interrupts are, the first hardware interrupt is, please answer these 2 questions. What is software interrupt and what is hardware interrupt? What is interrupt actually? The definition of interrupt. Exactly 402. Your good name. Reset hardware is the interrupt. Sandeep. Thank you, Sandeep, for immediately answering my question and telling your name. You are awarded with 1 like. Okay. From my side. Reset is the primary hardware input as an interrupt. Hanuman, this is exactly a textbook definition. Interrupt arises due to IO devices are called hardware interrupts. So whenever a hardware device is connected and we ask it to program and make it to function, in middle of some task, then it is called as an hardware interrupt or software interrupt. And one, please justify this. Just you are telling interrupt is something interrupt when we interrupt something. So how we are going to interrupt as a software and how we are going to interrupt as an hardware? As Sandeep has answered, when we press the reset button, this is an hardware interrupt which is directly passed to the microcontroller board. And apart from reset button, we have power cable also. The power cable, when you plug in and plug out, this is the primary basic hardware interrupt. Power on reset and power off reset. This is called as power on reset and power off reset. This is highly possible only whenever there is complete shutdown of the system. Usually when we see in commercial products like escalators or lifts anywhere in big shopping malls, whenever they want to do service for a lift, what they'll be doing? They'll be completely power offing the lift. That is the main interrupt or the hardware reset, which is power on reset supplied to the microcontroller board and the interface motor. As we have classified, the interrupts are of two types, software interrupt and hardware interrupt. The programmable interrupts all are called as software interrupts. And the buttons or the wires, whatever we are connecting it to the hardware, are called as hardware interrupts. Clear? Right. Going to the next slide. Comparison between Node MCU and Arduino. As we are familiar with Arduino, okay. So microcontroller is ESP12E module and Wi-Fi chip ESP8266 and Arduino Uno board with Atmega 328 microcontroller. Built-in Wi-Fi. Node MCU has built-in Wi-Fi and Arduino has no built-in Wi-Fi device. Cost, it is generally cheaper, whereas can be more expensive. Like Arduino Uno, Arduino Duo, Arduino Mega, Arduino Lilipad, and all these boards are there. Okay, all these boards are little bit expensive than Node MCU. Clock speed 80 megahertz and 16 megahertz. Memory 160 KB and it is 2 KB. Programming using Arduino IDE, MicroPython or Lua script. Only Arduino IDE can be used to program the Arduino boards. GPIO pins, 10 GPIO pins. Here we have 14 digital pins and 6 analog pins. But all these 10 GPIO pins are having multiple purposes and multiple interfaces, multifunctional as an advantage. Operating voltage 3.3 volts and 5 volts. This is having lower voltage. And power consumption is higher on Node MCU. Why? Because we can interface as many peripherals as it can be interfaced. Whereas Arduino board can be interfaced with low peripherals. So it will be consuming lower energy. USB interface, micro USB and USB interface type B, that is printer cable. And micro USB is related to the charger, micro charger. Flash memory is 4 MB and 32 KB in Arduino. Easy to use, moderate, more complex setup, high, very beginner friendly. Yes. So comparatively to the setup of Node MCU and Arduino, Arduino is very simple for the installation or connecting the board and writing the code and just programming the microcontroller is very easy in Arduino. But whereas coming to the Node MCU, we need to do some settings in the Arduino IDE to connect it to the laptop for the serial communication using USB to UART to dump the code on the microcontroller of ESP8266 Node MCU. community support growing, and the Arduino community support is extensive. Community support is nothing but like blogs or some articles in the internet. Compatibility shields. Compatibility shields means like RF. Sometimes we have GPS. Sometimes we have gyro sensors. Sometimes we have some battery packages. So that kind of shields are limited access to the node MCU for the interface, and for Arduino, they have wide variety of interfaces. So the feature ideal for IoT projects, Wi-Fi connectivity, cost effective. Simple projects, quick prototyping, low power, Arduino boards. Clear this slide comparison about node MCU and Arduino. Yes, Raja Vasavi, you are following my slides. Thank you. Applications of node MCU. As we have seen, node MCU project can be used in a Wi-Fi mesh network for IoT projects, home automation systems, and sensor networking, wireless sensor networking, and prototyping and development. So I can tell you, you can build a Wi-Fi mesh network using ESP8266. This is a simple project. So if you have a 3-store or 2-store building, you have a wired internet at your home. From the router, you are connecting it to the master ESP8266 node MCU. Okay, that is on the ground floor. And you are connecting another second ESP8266 node to the first ESP8266 node. Then these two ESP8266 are in mesh network with your router, network router. Then you can connect wide range of Wi-Fi network in your home for mobile, laptop, or any electronic gadget. This is how you can improve the signal strength of your Wi-Fi using Wi-Fi mesh network. That is the main application of a commercial project using node MCU. Is this clear? The example. So typically, as per the textbook, Sandeep, I can say that they will be giving an example of 500 to 900 square SFT. It can cover a range of Wi-Fi mesh or Wi-Fi distance, whatever you are asking Wi-Fi range. And the Wi-Fi transfer rate is, which is nearly approximately 60 megahertz, which is comparatively low when it is compared to our commercial routers. But we are every time connected to the internet using this Wi-Fi mesh network. Hope I am clear, Sandeep. Did I answer your question? Mr. 402, Sandeep. Do you have any questions, sir? Max data rate in Mbps, I have never tested, and theoretically also I have not calculated. We need to test it. Okay, so I'll be giving you this test result in the next class, as this is a good understanding about node MCU. If we want to build our home mesh network using node MCU, what is the max data rate? Okay, I'll give you this answer, Sandeep, in the next class. I have never tested this. Okay. So hope for today we will end the class. Sorry, so I was a bit late from the office today. So from next class I will be on time. Okay. So we will be covering from 7 to 9 as usual. Kindly excuse everyone. This is my humble request and last request. Okay. So we'll stop the session for today here, and we'll continue further in the next class from slide 15, and we'll be going into the example and practical part of our NodeMCU ESP8266, how it will be connected into the IoT. Sure. Hope we'll end the session here. If you have any questions, I'm here to answer. So the documents, everything will be shared from the Blackbucks team. Okay. Bye.